Hello, everyone. My name is Keith Jackson, and welcome to Jack's Math Notebook. Right now, you're looking at the fifth video in a series of videos related to understanding the rules of exponents. And today, we're going to continue our understanding of the power product rule, keeping in mind that we keep the base and multiply the exponents. And we have four big examples to show you how that's done. And so let's take a look at big example 5, in which we have the quantity of 7x squared y to the third power, all that raised to the fifth power. And so let us raise 7 to the fifth power, and what we get 7 to the fifth power. And what does that look like? That looks like 7 times 7 times 7 times 7 times 7, which, by the way, equals 16,807. Okay, so we have what that means. And so let's go ahead and raise x to the second power to the fifth power. Again, paying attention to our power product rule, we're just going to multiply those exponents, and we're going to get x to the 10th power, because 2 times 5 will give us 10. And let's do the same thing with y to the third power, raising that to the fifth power. And now we have y to the 15th power. And so our answer in this case is 7 to the fifth power, x to the 10th power, and y to the 15th power. And let's move on to big example 6, in which we have the quantity of negative 3m squared n to the third power, and that entire quantity is raised to the second power. And so let's raise negative 3 to the second power, and here's what we're going to have in this case. We're going to have a negative 3 times a negative 3, and here's why it's going to equal a positive 9, because if you remember the rules of multiplying integers, a negative times a negative will give us a positive, and that explains why we have a positive 9 in this case. So let's raise m to the second power to the second power, multiplying the exponents, because this is the power product rule, by the way, and that will give us m to the fourth power, because 2 times 2 will give us 4. And we're going to do the same thing with n to the third power, or n cubed, and we're going to multiply the exponents, and that will give us n to the sixth power here. Now let's move on to big example 7, in which we have the quantity of negative 2 p to the fourth power, q to the fifth power, and that entire quantity raised to the third power. Now let's raise negative 2 to the third power. And so here's what we have right here. It looks like this. A negative 2 times a negative 2 times a negative 2 will give us a negative 8. And you're probably wondering why we got a negative 8. Well, here's why. Because a negative 2 times a negative 2 will give us a positive 4. But we have a positive 4 times a negative 2. And if you remember the rules of integers, a positive times a negative will give us a negative. And that explains why we have a negative 8 here. And so let's raise p to the fourth power to the third power. And of course, we multiply the exponents, and now we have p to the 12th power. Doing the same thing with q to the fifth power, raising that to the third power. Now we have q to the 15th power. So our answer is going to be negative 8p to the 12th power, q to the 15th power. And let's move to big example 8, in which we have the quantity of negative 4 p to the third power, q to the third power, and that entire quantity raised to the fourth power. And let us raise negative 4 to the fourth power. And it's going to look like this. A negative 4 times a negative 4 times a negative 4 times a negative 4. And that's going to give us 256. And again, when you multiply two negatives together, you're going to get a positive. You multiply these two negatives, you're going to get a positive. 16 times 16 will give us 256. And that's why we have a positive 256 in this case. And again, we're just going to do the same thing as we did in the other three big examples. P raised to the third power to the fourth power will give us p to the 12th power, because 3 times 4 will give us 12. And likewise, we're going to raise q to the third power to the fourth power, and that will give us q to the 12th power. And so our final answer in this case is 256p to the 12th power, q to the 12th power. You have been given quite a bit of information, and I wouldn't blame you if you need to pause right here and give this whole thing a once-over, or replay this video as many times you need to gain a deeper understanding of the power product rule. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you, and have a great day.